All right, last time we talked about the basic power rule and basic integration rules. Now we're going to generalize that basic power rule and talk about the general power rule. So if we have some function of x raised to the nth power dx times f prime of x dx here, then we're going to have f of x to the n plus 1 over n plus 1 plus c 1 over n plus 1 f of x to the n plus 1 plus c. And that looks really confusing to me to have those f of x's in there. So we're going to learn something called the chain rule. And we say that this f prime of x, we can express that as some u prime or du dx. So when I take f prime of x dx or u prime dx, that's du dx. With a dx over here, it's like multiplication, where that cancels out and we get just du. So another way that we can write this whole thing is that if f of x is equal to some variable u, and f prime of x is equal to u prime or du dx, then this could be written as u to the n, and then this f prime of x dx is the same thing as du, and that'll be u to the n plus 1 over n plus 1 plus c, or 1 over n plus 1 u to the n plus 1 plus c. This is called our general power rule. You know, your book prefers to write f of x's, g of x's, things like that. I prefer to do u substitutions. We'll actually do some practice with u substitution here in the next video. We're not going to need any u substitution right now because they're going to give us functions where we have the inner function here in the composition of functions is going to already have the exact derivative of it on the outside. So let's take a look at what I mean about this being a composition of functions. Number 9, the integral of, and in parentheses, is x minus 1 raised to the 4th dx. If I was going to try to use u substitution here, I'd let u be my inner function, x minus 1, and then du dx would be the derivative with respect to x of x minus 1. Du dx would be 1, and so du would be equal to dx. And I'd make a substitution here. And I'm just showing you how to do this time. We're not going to do this every time. We're going to do this more in the next video. But this would be u to the 4th du. And I'd make this u to the 4 plus 1 over 4 plus 1 plus c would be u to the 5th over 5 plus c, or 1/5 u to the 5th plus c, and I'd have to back substitute to get it back in terms of x. So u was x minus 1. Now let's go back and let's do all that without the u substitution. And you'll see that because the exact derivative of x minus 1 is 1, and there's already a 1 on the outside right here, we don't need u substitution. we can just say we're going to take this expression here, use the power rule on it because I have the exact derivative on the outside, and we're going to call this x minus 1 to the 5th over 5 plus c, or 1/5 x minus 1 to the 5th plus c. You cannot use this rule until the exact derivative of the inside is on the outside next to the dx. So let's look at number 11. 11 says integral of 7 minus 2x times a negative 2 dx, and we see that this is squared here. So the derivative of 7 minus 2x is negative 2, which I have right there. So that's good. So I can increase the exponent by 1 here, divide by that new exponent, add my constant of integration. Maybe I want to call that 1/3 instead of divided by 3. It's the same thing. Let's look now at number 15. Number 15 says integral of the square root 4x squared minus 5, and I have an 8x dx. Let's just confirm that the derivative with respect to x of 4x squared minus 5 is 8x. Check. So I have, this is the same thing as 4x squared minus 5 to the 1/2 power times 8x dx. So this is going to be 4x squared minus 5 to the 1/2 plus 1 over 1/2 plus 1 plus c. We've done this before, that 1/2 plus 1 is 3/2, and dividing by 3/2 is the same thing as multiplying by 2/3. And this is kind of the one exception that I make to going back to the form that I started off with, is that if I started off with a square root like this, I'm probably not going to try and get a root because it looks messier to get the root to show back up. I'll probably just leave it as a fractional exponent. So there that is. That was number 15. Let's go ahead and look at number 17. (6x over 3x squared minus 5 raised to the 4th dx). So I'm going to want to write this as 3x squared minus 5 to the negative 4th times 6x times dx. Just verify that 3x squared minus 5 has a derivative of 6x, and it does. So we're going to make this 3x squared minus 5 to the negative 4 plus 1 over negative 4 plus 1 plus c. 3x squared minus 5 to the negative 3rd over negative 3 plus c is a negative 1/3 here, and then 3x squared minus 5 to the positive 3 in the denominator. Just leave that negative 1 in the numerator up here, and that's it. That gives me the positive exponent in the denominator of the fraction, just like I started off with. All right, let's look now at number 19. Number 19 says x squared 2x to the 3rd minus 1 raised to the 4th dx. Now things are not written in the order that I want here because I have my composition of functions written second. So I want to make this look like this. I might need to do a little bit of adjustment on this one. They haven't made us do that yet, but let's take the derivative with respect to x of 2x to the third minus 1, and that's going to be 6x to the second. So now I need to end up with 6x to the second on the inside. I'm going to multiply by 6 on the outside. I'm going to multiply by its reciprocal on the outside. 1/6 times 6 was 1, and I didn't change the problem at all. Just changed the way that it looks. So I now have 1/6 integral of 2x to the third minus 1 raised to the fourth, and I have 6x squared dx, where 6x squared dx is the exact derivative of 2x cubed minus 1. So that gives me 1/6 2x cubed minus 1 to the 4 plus 1 over 4 plus 1 plus c is 1/6 times 2x cubed minus 1 to the 5th over 5 plus c. 6 times 5 is 30. 2x to the third minus 1 raised to the 5th plus c. Let's look now at number 21. Number 21 says the integral of t square root of t squared plus 6 dt. So I already see my composition of functions is going to be t squared plus 6 raised to the 1/2. I'm going to need a t portion here, but I think I'm going to need a multiplier. So derivative with respect to t of t squared plus 6 is 2t. So let's make that happen. We need 2t. So we're going to balance that out with a 1/2 out front. 1/2 integral of t squared plus 6 to the 1/2. 2t dt is 1/2 t squared plus 6 to the 1/2 plus 1 divided by 1/2 plus 1 plus c is 1/2 t squared plus 6 to the 3/2 over 3/2 plus c is 1/2 times 2/3 t squared plus 6 to the 3/2 plus c. 2's will cancel and leave me with 1/3 t squared plus 6 to the 3/2 plus c. Let's look at number 23 now. Number 23 says the integral of, and the numerator is x to the 4th, and the denominator is 3 minus 2x to the 5th, all raised to the 3rd dx. So I'm going to make that 3 minus 2x to the 5th raised to the negative 3rd x to the 4th dx. I'm going to check my derivative of my f of x here. So if my f of x is 3 minus 2x to the 5th, my f prime of x is negative 10x to the 4th. So I need to multiply inside by negative 10 and outside by negative 1/10. That gives me negative 1/10. Integral of 3 minus 2x to the 5th to the negative 3rd, negative 10x to the 4th dx will be a negative 1/10. 3 minus 2x to the fifth to the negative 3 plus 1 over negative 3 plus 1 plus c, negative 1/10, 3 minus 2x to the fifth to the negative 2 over negative 2 plus c, negative and a negative will make a positive. 10 times 2 is 20, and we want positive exponents here. So let's go ahead and bring this down. 3 minus 2x to the fifth raised to the second. This was a positive 1 in the numerator this time, plus c. All right, let's look at one more problem for this video, and that'll be number 27. 27 says the integral of x squared plus 3 over, and the denominator is x to the third plus 9x plus 4 quantity squared dx. So we have x to the third plus 9x minus 4 to the negative second, and I have x squared plus 3 dx. All right, let's see what I need to do to x squared plus 3 to make it f prime of x dx. So we have f of x is equal to x cubed plus 9x minus 4. F prime of x is equal to 3x squared plus 9, which has a common factor of 3. X squared plus 3, and I have x squared plus 3. So I'm going to divide by 3 on both sides and say 1/3 f prime of x is equal to x squared plus 3. And make that substitution here and say that this is f of x to the negative second times 1/3 f prime of x dx. That 1/3 is going to come out front. And I want f of x to the 1/3 f of x to the negative 2 plus 1 over negative 2 plus 1 plus c is going to give me 1/3 of f of x is x cubed plus 9x minus 4. It's going to be raised to the negative first over negative 1 plus c. And that's going to give me negative 1/3. Then this drops down to the denominator, x cubed plus 9x minus 4 plus c. So let's put that negative 1 right up there. All right, and that's it for this video. We'll come back next time and do a little bit more with u substitution that I talked about in this video. We'll just do a couple u substitution problems with a skill called integration by substitution. So see you for the next video.